Okay, let's take a look at these graphs here. This is a rose. Why is it called a rose? Well, we'll see in a second. Okay, so first of all, no adding or subtracting when you look at this, and 3 theta as opposed to the circles just had 1 theta. So, plugged it all in. This is what the rows look like. Here is 4, 0, or at 4 at 0 degrees. This would be 4, 2 pi over 3, or 120, since we're in degrees on the other one, and 4 pi over 3, or 240. So we're going to go ahead and sketch that. Over here, here's 4, 0, 4, 120, and 4, 240. Now you don't have to go ahead and do it the way the pattern does it, but I'll show you that pattern in a second. So it comes up like this, through the origin, around there, up through there, back around, back through the origin, and not my best shot at it. Don't know what the problem is. Okay, so anyways, really what it looks like, and this K is where we're dragging it. So you can see the pattern as it goes around. And notice, let me back it up a little bit, that's about pi right there, and the whole thing's completed. So the second time around, it's going around from pi to 2 pi, it just goes right upon itself. Let's ask these questions. The length of the leaf. So if these are all lengths, each length is 4. Number of leaves, how many of those? 3. And what about the spacing? So from here to here to here. Well, we could see here, here, and here it's 120 degrees. But if we have 3 leaves going around the entire circle, how else can we get that? Now, where's the first leaf? The leaf closest to 0, and in this case it happens to be 0. We'll show why that happens, or whether we get that in a little bit. Okay? So moving on to the next one. Taking a look at what we had before. This is still going to be a rose. No change there. Okay, now what about the length of the leaf? Well, up here, length of the leaf was 4. Where do you think we get that from? Right there. There's your length of the leaf. And so down here, the length of the leaf, what's the coefficient? How many leaves? Well, let's take a look at, first of all, how many leaves. Let's look at the graph. Well, here it is. I'm going to go ahead and take a look at, scroll through the angles again. So, taking a look, starting out, going around, there's the length of the leaf, 6. By the way, what angle does that sort of look like? It's going to be hard to tell maybe from the decimal. 0.8? We'll take a look again. And we'll go around and around. By the way, there's pi. Looks like looks like there's missing. Yep, we keep going. So how many leaves are there this time? Exactly. So now we've got 4 leaves. Now if we put 4 leaves evenly around the circle, 360 in degrees, or if we're dealing with radians, 2 pi divided by 4. Now that first leaf ended up being at pi over 4, or in this case 45, and then 90 more than that would be at 135, 215, 225, 315. Now if you got carried away and added 90 again, boom, you're right back here but a coterminal angle. So now you don't have to do that loop-de-loop try to thing. You can just go ahead and draw 4 leaves coming out from the origin, like that, like that. Now, they can touch a little bit, but don't make them overlap. Yeah, for some reason this is just not being as precise as I like. So there's your 4 leaves. That's good enough. Now, and how do we get this location of the 4th leaf? The first leaf. That's going to be that's really where the crux of the issue comes in. And really, that's the only place we got to use Trigger Bra. So, again, the leaf is how long? So that means in this case right here, R equals 6. So when is 6 equal to 6 sine of 2 theta? Well, solve for theta. Divide by 6. Now, here's the thing that I like to do. I like to shortcut that step because I know the radius equals this each time. Really, what we're looking for, when is the first time that trig value is equal to 1? So when is the sine of what angle? The sine of what angle is 1? Well, that angle then has to be 90, making theta 45. And that's where it was. And that's where it was. Okay. So if we just would do that back here, let's take a look at this one up here. Do the same thing. If we wanted to go 4, the radius there is 4 cosine 3 theta. So where's the cosine of 3 theta equal to 1? So cosine of what angle is 1? Well, it turns out when the angle is 0, when this here is 0, the cosine of this stuff, cosine of 0 is 1. Well, if 3 theta is equal to 0, theta then is also equal to 0. And that's how you get that. By the way, let's just verify that thought. I'll just leave this here. Well, first of all, how can we get what thought you might be asking about? But how many leaves? I don't see 4 anywhere in here. But notice that's an even number. So if we take 2 and times the coefficient of theta here, we do get 4. But this is an odd number, odd coefficient here in example 1, and we didn't. So even coefficients we double, odd coefficients we don't. Let's double check on this one here. So again, this is just coefficient, that's even, so we had 4. So when we have 3, an odd number, we have 3 leaves. 4, even, we should have 1, 2, 3, 4, 5, 6, 7, 8. 5 should only have 6, should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we have an even coefficient, we double. For the number of leaves, if it's odd, we keep the same. So let's look at that over here in example 3 first. Walk through the whole thing. So again, no addition and subtraction. 1, not 1 theta, just something other than 1. So we got a rows. The length, what's the coefficient of the trig function? Number of leaves. Is the coefficient of theta odd or even? It's even, so we double it. Gives us a total of 8 leaves. So the space, the whole circle, we're spacing 8 of those all around the circle. 360 divided by 8, 45. So we know how far out, we know how far apart each leaf is. Where do we start? Well, that again is Trigger Bra. Where is 3 equal to 3 cosine of 4 theta? In other words, where is the cosine of 4 theta? Equal to 1. What does this stuff have to be? The cosine of what stuff is 1. Again, the smallest angle, and that happens to be 0. So location of first leaf is 0. So out here at 1, 2, 3 for the length, starting at 0. Now we're going to go up every 45. 45, 45, 45, 45, 45, 45, 45. That should be 8. And if you actually kept going, hey, wait, you should end up where you start. And then draw your 8 leaves. You don't have to do that pattern. You can just do stuff like that. Again, we know there's a pattern. We know these are all connected, continuous. And try to draw it a little bit like so they don't overlap. A little bit is bound to happen because of the smallness of the graphs, but it's not terrible. It's not really bad. It's not like you're trying to draw. If you were trying to draw things like this, things like that, or that, where it's really obnoxious, yeah, that's no good. Otherwise, you're okay. So up here, the length of the leaf, that's A. The number of leaves. If B is odd, then there's B number of leaves. If B is even, it's 2B number of leaves. One more time, one more walkthrough. Again, it's a rows. No addition, subtraction, other 1 theta, it's not 1 theta, it's 5 theta. Length, number of leaves, odd or even. Space, so 360 divided by 5. And how about the first one? Well, where is 4 sine of 5 theta equal to 4? In other words, where is the sine of 5 theta equal to 1? Well, that means sine of what angle is 1? Well, sine of 90. Divide by 5. Uh, 18. 18? Yep. So we're going to have to guesstimate on these here. So 18 degrees, these are every 15. So 1, 2, 3, 4. Here's 15. 18 plus 72. Plus 72. So that's 182-ish, I think. No, not 182. 162. So 150, 165 in here. Again. So 1, 2, 3. So 1, 2, 3. That's 60. That sorry. 15, 30, 45, 60, 75 would be the next one. So it's a little short of that. Again, 15, 30, 60, 75. And if we were to do it again, oh, where'd I lose? I lost my R. So it's out here. And then draw them out to there. Oops, missed that a little bit. Boy, it does not look neat, but it's good enough for what we've got now. Okay.